and our project is entitled Real-Time AI Research. So, imagine you are the generic, frustrated data scientist pictured here. You are you're running lots of machine learning experiments on your local machine. You're trying to optimize lots of different functions in various ways. There are many different approaches for how to do this. So for example, we have Gaussian process optimization is a class of algorithms that you can use to optimize your functions. So the task that we have is to make this an easier process. Imagine that you're trying to run lots of experiments concurrently. Each one has different hyperparameters and different approaches, and you have 10 terminals open on your machine, each one pasting lots and lots of numbers into your face. And it's hard for you to see which ones are running well, which ones are failing, how to tweak parameters to make things run better. What you want is a web interface or a remote application that allows you to manage these things concurrently and shows you visual summaries of the data, and then in the end allows you to kill experiments which are not running correctly and modify the parameters of those that are, so that you can progress towards an optimization algorithm that works best for your given data. The way that we achieve this is using this kind of topology. We have an Angular web interface that interacts with the Java server, and the Java server does all the concurrent management necessary to allow you to run machine learning experiments concurrently. The library that we use for machine learning is called GPyOpt, which is an amazing library for machine learning optimization algorithms. And we've essentially provided an interface that allows you to interact with that library in all of the various ways that that library supports. Now Shivan's going to talk to you about what we provided.
Okay, so the first page that you essentially would like to land on would be the page to start the experiment. So here you could give it an experiment name, and then there are a lot of hyperparameters that you want your model to use. So there's the model parameter from where you can choose multiple types of Gaussian models. There's the specific acquisition function that the algorithm will use to obtain the next data point to evaluate your model at. And then there's a jitter value, which kind of encapsulates the concept of exploration in your machine learning model. And then there's the domain. So you give it what kind of space do you want to optimize on. So then after that, there's the resources tab, which here you can give the number of iterations that you want to run the model on. Is there a maximum kind of runtime cutoff time that you want? So to just cut it off at this particular time. And if you want to run the experiment parallelly in using multiple cores, you can give it as many cores as you want. Then you enter your objective function with this is the function that you're actually trying to minimize in your experiment. So the function that you need to provide is supposed to be in Python code, but theoretically you could give any neural network optimization function here. So all we require is the problem should be a minimization problem, and mostly all of the optimization generally is to minimize your loss. So after you have entered your objective function, then you can click on the finish button, and this will send the request to our web server to start the experiment in Python, and then it'll send you to this particular page. So this page will give you two graphs which are rendered in real time as your kind of model, as your optimization progresses towards finding the minimum value. So the first graph kind of represents the distance between the two consecutive x values that you choose. So the way that the algorithm works is that it gives you an x value to evaluate your objective function at. You give it the output that after you evaluated the function, and then it takes the output, does some processing, and gives you the next x, which is more likely to be closer to the minimum value that you want. So the sample data kind of gives you what the minimum value, like how close you are to the minimum value, and the minimum value graph itself, as you can see, is just the graph of the minimum value itself. You can monitor all of the running experiments from the dashboard, and there's also functionality to generate reports after your experiment is over, which gives you all of the details of the optimization. And there's also error reporting. So if you make some sort of error in your parameters, or if there's a syntax error in your objective function, you get a detailed error stack trace so that you can debug your model and restart your experiment. And that's pretty much it. I'd like to thank our client Javier for being super awesome, and thank all of us thank all of you for listening.